So here's the second Harvard 420M for 2 day, and we'll test both these together. This is Craig's. We've done Dave's, this is Craig's. Right. Well, blow me, it's got a factory original mark just like the other one. It's like buses are all coming together. Right, we'll whip the screws out. Connect it up to the test equipment. Now this one's had a crystal filter fitted. Not something we would get involved with, but as long as it works, it can stay, can't it? So that's there, but you never know whether they've done the correct type of termination with them, and this is always my worry. So, I can't see anything there shouldn't be. I'm still just about a smell of cybernet there. Put the mic in. And so negative nearest the case edge. Now that volume control is too stiff, so I need to do something about that, and that's clean some of the grease off. It's a bit noisy, so we'll clean that as well. So once again we'll go through how this is doing. So if you remember, Dave's came out doing 2.9 watts initially. See what this one's doing. Let's put picture in picture on. It is on, but it's not showing the right camera. Now it is. So doing 3.2 watts. Deviation. Wallow is about spot on. I'm going to say it's 2.6. Frequency. Channel 21. Is this the one that's not doing all the channels or something? Right. Pause the video, I'll take the other lid off. So it's not selecting channels properly. The first thing we're looking at is whether there's a break on the printed circuit board, and it looks to me like this one's open circuit. We buzz that one through, and that one, and that one, and that one, and that one, that one, that one, nothing on that one. So where's Mr. Chippy's toothbrush? What's supposed to happen is if it gets an incorrect code, it's supposed to lock out and not transmit, or select channel 9. That's reading now, but I don't know how reliable that is, so I think we'll put a bit of a jumper wire there. There's also potentially a dry joint could happen just there. I think we'll be having the front off this and just making sure that the channel selector knobs or controls securing nut is firm. Right, I'll switch the set back on, still on channel 20. No change whatsoever. Right, we'll switch it off, run through the soldering of the phase lock loop chip. And of course the phase lock loop chip could be faulty. Switch it on. Nope. This side of it just affects the display. So when we go to channel 9, it should be 68125. Unless the crystal's duff. Let's see what it's actually transmitting on. Let's say it's 27.6663. So we'll put that on the signal generator. See if it actually receives. And it does. That's fine. So it's just miles off frequency. Well, the first thing, I wonder if we can just see if the 10.24 is anywhere near 10.24. I'll go and get the little oscilloscope. Right, so if we get Mr. Chippy's earth onto earth, .2333 is low, isn't it? Kind of get my trimmer in one side and see if I can adjust it with the other. We're just going to change the crystal. So having changed the crystal, we're on channel 9. Let's change it to channel 20 and see whether we are. Yes, so it's the Duff crystal. Now this is going to cool down because obviously I've been soldering it. Excellent. So we'll do the VCO. Put the replacement crystals away. I was going to think it was going to be the phase lock loop chip, but the crystal's cheaper. So, as ever, got to see what the service manual says, because I've only done it 2 hours ago. So, select channel 40. And in receive we should be 4 volts plus or minus 0.1, so we'll just give that a little tiny fiddle. It really doesn't need changing. Transmit 4 volts plus or minus 0.1, it's now CT1. Receive, transmit. Now go to channel 1, 1.8 to 2.5 on channel 1, we're at 2.1, and then on receive 1.9 to 2.5, so we're done. That's a slight adjustment there, didn't need it. but just for the demonstration. We did that on Dave's, we'll do it on Craig's. So it was miles off frequency. So see what it reads now. On channel 20. Excellent. Okay, so now we'll look at receive. So switch the sine meter on and see how well this one's working. So it's doing 0.3 of a microvolt. And for 20, doing 0.75 microvolts for 20 dB sine. So this receives less noisy than the previous one, but it's no difference in sensitivity at this stage. See if we can improve that. So next we're just going to tune up the transmitter, and then I think it's tea time. Let's go to that. So maximum, maximum, maximum. We're at about 3.2 watts. So now with the other three, these need to be put to maximum and then adjusted from there. So that's 4.4 watts, 4.4 watts, 5 watts exactly. Just check they are max. Yep. So now L4 goes clockwise for 4.4 watts. That's there. And L9 goes counterclockwise for, it says 3.8 watts. But we are going to set it for 4. And then we're going to verify where we are with that. Because really we want it between 0.2 watts within the 40 channels. So channel 1 is exactly 4 watts. Channel 40 is exactly 4 watts. They're all on frequency. Job's a good un. So now we'll do the power meter. Let's see what it says. Just over 4 watts, so we'll just reset that. Now we'll check low power. So it should be 0.4 of a watt, so it should read there. It's 0.1 of a watt. These are often dirty and sometimes knackered as well. Just give it a waggle around. 4.4, and on the other scale, go back to normal, we've got the 4. So that's that done. Deviation. So I want this one to the central position, is it 6? And then we'll check the deviation now. Voila, it's a bit over the top, but not stupidly. Wallow. Wallow. Yep, it is. So that's now reset to 2.2 to 2.5. So that's done, frequency's done. Low power's done. Let's have a quick look at receive. So we'll go to the oscilloscope. Put that trimming tool back, we're done with that. So we want S9 equivalent on the signal generator, 100 microvolts. We'll put that on the camera and we'll turn the bench light off. And with the correct trimming tool, it is the detector coil there for maximum recovered audio. And there was no improvement there. So we'll go to the synad meter, and as I say, we keep the signal generator as low as is usable, and as we improve the set, if we improve it, we drop the attenuator further. So we'll start at the front end. It's got the extra, it's got one of the extra coils, hasn't it? No improvement there. No improvement there. No improvement there. Bigger signal for the IFs. Very slight improvement there. Remember, this has been crystal filtered, so it might not perform as I'd expect. Looks about right. So let's read off the synad now. So 12 dB, we've got 0.29, and it was 0.3. So as good as I can get it. And then let's look at 20 dB. Have we made it better or worse? It's now 0.66. Very good. So this receives marginally better than the other one. They both transmit the same. So we'll get we're done with that. We'll take that off, we'll put this to the attenuator. Turn the volume down. And look at the S meter. So it should read S9. And it's 7 and a bit, so we'll adjust that. And now we'll look at the squelch. You know what? RF gain wasn't at full. Let's just check that again. We'll look at the sensitivity again. So I don't know whether I caught it. Turning it over. Well, this time I'm reading actually 0.7, so it hasn't. No, I must have knocked it turning it over. It wasn't the sensitivity. Right, so back to bench light on. We were doing the squelch. I want 100 microvolts on the test set, and we'll turn the squelch to full, turn the signal generator down. This is weird. It's actually very noisy. You can hear it. And let's look at it at the sensitive end. Set threshold. Signal generator off. Very noisy. Coming about 0.3, leaving about 0.2. This makes me wonder if the squelch switching transistor is faulty. I think we'll look at that after tea. Okay, so the next day, chasing this squelch around, replacing a couple of capacitors, checking the transistor 14. I then looked on a scrap chassis which has R60, which this didn't. I've included R60 now, the squelch works. So I don't know what that was all about. Someone's taken R60 out and put a wire link to ground, I think, or something. Anyway, let's see if we can set it up now, because that's where our stumbling block was. So squelch to full. Actually, it is correct as I set it. There's 30 microvolts. There's 100. It opens. So let's now see where the sensitivity is. Actually, no, it's 30. Just knock it up a fraction. That's it. So now 30. We've parked the signal generator at 0.3 of a microvolt. Set the squelch. Put the signal generator back on. See where it comes in. Comes in 0.7 of a microvolt, and it goes out at 0.62 of a microvolt. So that's fixed that. So there are some daft modifications to go around. I'll just see if the bar out on the display is anything we can sort out. But other than that, I think we're there. A few days later, as they say. Well, this has been an absolute swine, and I think had we known what was wrong with it, we'd have declined. I'm going to look after him because it's going to cost us a lot more than it's going to cost him. So I've had to change the display on this, and the only way I could do that was to pinch one off my own working set. So I'll just go through that. okay. Now those displays are the same ones as the Midland 3001s, the green 22Ps I think they are. And what I've done is to order something which may well work and may something like fit from RS, and they'll come on. One of those will come on Monday. You know, I'd like to know if there was something available. If anyone knows what's available in green for these common anode requirements. And I don't mean about a one-off on a scrap set or some old stock from somewhere, something that's current and I can order 25 of. It's I've spent a lot of time looking through the specifications, and the one offered at RS, we may have to bend the pins a little bit because there's 2mm difference from one end to the other. So we'll have to see how that works out when it arrives on Tuesday, and that's what I'll put back in my own set. So what value is a display? Should I charge him a cheeky quid? I'll tell you how much the replacement is from RS. It's $5.75 plus VAT, so, and that's trade for one. But that's one difficulty. The other difficulty is when I came to it, when I cleaned the printed circuit board with isopropyl alcohol, because we've changed the audio IC in fault finding the squelch fault, and it turned out there was that resistor missing. So I was cleaning this up and put it back on. It doesn't work. In actual fact, at some point in this radio's life, the channel selector has not been there's a nut on the channel selector switch, and that nut must have been loose or missing or whatever, and so there's been a lot of mechanical strain on the printed circuit board. So I did spot a crack early on in fault finding, and I've ended up putting jumpers on 4 of them because it's in that kind of a state. So of course, if you've not got the channel selector switch bolted to the chassis, let's look at this scrap fake Amstrad. It's the same kind of, no it's not, a totally different channel selector switch. So it's bolted to the chassis with a nut there, but if that nut wasn't there, every time you change channel, and of course they're quite tight, there's a lot of things happening, it breaks away from the printed circuit board, which is what's happened here. So as a bit of a belt and braces, I've put some jumper wires in. But of course the same's happened on the top side of the board. So, you know, we've done our best there as well. But there's a bit more flexibility on the top board, isn't there? Because it's held by that ribbon wire, which luckily hasn't failed. So now we've got a nice working set, and all the channels actually light up. So I think the biggest headache was the no squelch. For somebody to have removed that resistor, absolutely bizarre. Because they obviously didn't like the clunk of the squelch action, and so they didn't want proper squelch action. And all it did was kind of reduce volume, but that volume never went away because you've removed the earth from the very switch that switches the audio IC to deck. Effectively it shorts the input out when the squelch operates, and so that's why if the transistor's not faulty and the capacitors aren't faulty, because we've changed all those, the next course of action is the audio IC, because the preamp in there is doing the squelch action. But then of course if somebody takes that resistor out, there you go. I'm not a mind reader, so I don't know where Craig's got this from. Perhaps he's owned it from new, he knows all about its foibles. But we've now got a nice working set, and we will put the lid on. If only I knew where it was. Oh, it's going to be that one, isn't it? Because he's 40 years old, and a lot of things can happen in 40 years. it's that one with the holes in the top. I have to check back on the video that I'm giving him the right lids back. So we just need to plug it into our aerial. I'll put a few of the screws in so it doesn't fall apart, and then we'll just pop it on the aerial, and we'll do a scratchy corner test back to back with Dave's. Now I've already recorded Dave's, his radio's actually gone back, so this back to back test is the way we've edited the video rather than it happening live. So it's a different day, but we're going to put the two tests on one video, because I think it would be a bit boring for two people to see two Harvard 420Ms working more or less the same. But it's apart from the holes in the lid, it's a nice-ish looking set, and it's just a shame that that channel selector switch has had the thing work loose, the nut work loose. I don't like crystal filters added. You never know whether they've been done correctly, but I don't reverse things like that unless the performance is so poor that it's clearly faulty. So 2 more screws to go. And we'll put it on our Antron 99 base aerial, which I've said before is mounted just above gutter level. This is a single story building, so it's not got the ground plane kit, which you can have and does improve performance. We've deliberately put this aerial in not the best position. I love shorting out this power supply of mine. Right, so we'll take that off. We know it's transmitting beautifully, we know it's receiving beautifully, and it's actually displaying the digits. I'd like to have done the next set today, but I don't know whether we're going to have time to even start it. We have got a great GT858. It is Sunday. We used to do Sierra Hotel 1 Tango set Sunday. I love great sets. Everybody else doesn't. Woo, squelch works. So what have we got on a Sunday afternoon? Perhaps they're all at church. 19 Roger. You wouldn't believe that, would you? That there's absolutely nothing going. 19 Roger. Nope. Okay, well, we'll do a scratchy corner test, and I've no doubt that'll work very nicely. So thanks for watching the Harvard 420M from 1981. This one is Craig's set, the second one we've done this week, and we'll see you on the air test.